Everyone, April 28th. Alright, it's gonna be a tough one. I don't know if I have enough Ghana after this to continue working on this. I mean, the thing is, I don't have a very good plan. I thought about it last night, but didn't really. I mean, the next idea I have is just to split into two. It's kind of my other idea, but other than that, I really don't have another idea going for it. Alright, anyway, let's try this one. Does everything swap to type? I just checked the TypeScript once and everything skipped to TypeScript. Similar string groups, two strings, X and Y are similar if we can swap two letters in different positions. Of course, if you swap at the same position. No, you just cannot swap in the same position. Two letters in different positions. Oh no, of X. Of course, a different position, so that it equals Y. Also, two strings X and Y are similar if they're equal. So if you can swap two to make them equal, they're similar. Or if they're equal, then they're similar. For example, tars and rats are similar because we can swap position 0 and position 2. So tars become RATS, that's rats. Okay. And rats are similar, but star is not similar to tars, rats or arts. Together, these form two connected groups by similarities. Tars, rats, and arts. So arts is similar to what? It's similar to tars? Tars and arts are in the same group even though they are not similar. Formally, each group is such that a word is in a group if and only if it is similar to at least one other word. So are you saying arts is similar to rats? Ah, yes, you swap R and A. Okay, we're given the list of strings where every string in strs is in an anagram of every other string. And how many groups are there? Holy crap. Oof. I mean, you're talking about groups. First thing in mind is union find. So we have handled the grouping part. This is union find. So now the thing is just we have to, and the length is 300, so we go O(n) squared, right? So the only thing left is to just decide whether two strings are similar. And one of them is already done, which is if they're equal. So now we only need to do the second part, is if we can make one into the other by swapping two letters. So that's the only thing we need to deal with, right? So the problem has been distilled to one problem. Given str1 and str2, which are anagram of them. So is str1 similar to str2, right? That is the only question. So we just need to write a function, okay, say is sim, right? Okay, say s1, s2. And how do we do this? Well, because there are only two, that's different. So if you lay s1 out, right? If they say this is s1, and if this is s1, this is s2. If you compare, right? If the only difference is 2, at two positions they're different, right? Because they're anagrams, right? So if we have this position and this position is different, everything else is the same, then we know we can swap these two. For example, tars and rats, right? if I compare A, S, so we have 1 and 2. So tars and rats, they're the same. Tars and arts, right? None of them on a 1 is the same. So we have 1, 2, 3 is different. So they are not together. And tars and stars, right? We have none of them is the same. So by this, we have tars and rats, right? They are in the first group. Now we go rats and arts. We have two different, so arts will union with rats. So arts is going to be here. And again, rats and star. None of them are equal. So last one is arts and star. None of them are equal. So in the end, we have one group is tars, rats, arts, and the other is stars. So that's why we have 2. So actually, this is not that hard. I mean, if you do not know union find, then I can see how this one can be challenging. But if you know union find, which now everybody should learn, then it's not really that bad. All right, we need to first do union find, which is okay. We just did it a few days ago. All right, we can do that. Yeah, we can do that. Parent is gonna be list range n and self.rank, and let's start with 0 times n. Right, def find self x int if self.parent x is not equal to x, self.parent come on, x equal to self.find self.parent x. This is to compress the path, and then we return this def union self x and y, return a boolean value px/py self.find x and self.find y. If px is not equal to py, if self.rank px is larger than self.rank py, then we say self.parent py will equal to px. If self.rank px is smaller than self.rank py, then self.parent px shall equal to py, else self.parent py shall equal to px, and self.rank px plus equal 1, then we return true, otherwise return false. Done. Okay, then we need to define another thing. Let's call it def is sim self s1 s2, return boolean value, right? Then we just say the number of mismatches, right? Then we just say for zip s1 s2, right, a and b, a is not equal to b, okay, and we can sum this thing. It's smaller or equal to 2. Yeah, so we return this, and then we say dsu equal to dsu n is going to be equal to length strs, so the n. Then we say for I in range n, j in range I plus 1 to n, if str I is equal to str j, or self.is sim s1. Oh, actually, if s1 is equal to s2, right? Return true. So I can just say if they are similar, right? If s1 and not s1, str I and str j, then we can say dsu dot union I and j, right? Blah blah blah. Then we want to return and let me compress it one more time, right? So we say compress path one more time. I in range n dsu dot find I. Then we'll return len set dsu dot parent. That I believe shall do. Two. This is 1. STRs. Num similar groups STRs. That is not right. Hold on. What was wrong? Perhaps you forgot a comma. Oh, for A, B, I don't know what I was doing. Sorry. Doesn't make any sense, right? Yeah. There we go. Disjoint. Disjoint. Wait, what does DSU stand for? Wait, what does DSU? Disjoint union? Is that disjoint union? Set union. Disjoint set union. That's what it stands for. Have you tried 1? Have not tried 1. So let's try 1. Just to make sure. Okay. Alright, not too bad, but maybe the performance can be improved. I don't know. The grouping part can be resolved by union find. In part. Thus, the only thing we need to worry about is determining whether 2 strings are similar. And 2 strings are similar if their differences are smaller or equal to 2. What if they have 1 different? No, that's not possible. 1 different is not possible. So only have 2 because they're anagrams. If they will not have 1 different. So either 2 different or 4 different. Yeah. So there will be O(n) squared times union. Now this, I don't know. Maybe if we don't compress, it will still work. Maybe the compressed part is. Maybe let's try no. Let's try do not compress to see if it works. I mean union. Yeah, I don't think we need to compress. It just in the past, sometimes like if I don't compress it and then it'll be wrong. Yeah, you see? You see that? You have to compress it one more time. So that's why you have to do the compress. Yeah, it's also we have to compress the path right at the end. to make sure, right? To make sure each element's parent, right, has been fully determined. Yeah, so you have to compress. Okay, so what are the solution? No, I mean the runtime. Wait, it's not that good. 2.12 milliseconds. 24.92%. Meh, it's all right. DFS, BFS, union find. Oh, and plus M. Yeah, plus M. How does DFS, how does this go into play? I never really given this any thought. We have 4 nodes. You can connect. Oh, yeah. Yeah. It is. It is. You build the adjacency list first. Yeah, you build a graph first. If they're similar, you connect them. So you, and then you traverse. DFS traverse. And after you traverse, yeah, let's do the DFS. Let's do the DFS solution. I think it will be interesting. DFS solution. Each pair that is similar can form an edge. Then we traverse the graph to find all the cliques. That's it. Shall be straightforward. So when I say graph equals default dict, that's about right. Default dict, right? And then we'll do this. But no DSU. That's just gonna be graph I dot append j, and then graph j dot append I, right? Then def DFS. Visited equals a set, and then there'll be a node int, don't return anything, and then we just say we're visiting the node, right? And visited, I'll add a node, and for child in graph node DFS child if node. I mean, it doesn't matter. That's DFS. If node not, I should do it here. If child not in visited, then we DFS it. Right? And then we can call for I, rest is 0, for I in range n. If I is not in visited, DFS I, and then rest plus equal 1. Then we'll return rest. Okay, that shall do. There's no solution 2. There we go. give this a shot. Eh. 2012, 2021. Oh. Okay, so that's not too bad. So we're done with this. You want to give this one more shot before we end? Okay, so I have one more idea. All right, so that's the initial one, and I think it's wrong. Oh, I have no submission because I feel this is wrong. So what I'm gonna do is I'm gonna use a new idea, completely new. Okay, completely new. What I'm gonna do is I'm gonna sort it first. Okay, and I equal to 0, ij equal to 0, and len nums divided by 2. Now, maybe we should do divided by 2. And what if it's like, because this, right? So we can start from, so 5 divided by 2 is 0, 1, 2. I think that's fine, right? As 4 divided by 2 is also 2, 0, 1, 2. Yeah, I think it's fine. And then we just say, while j is smaller, right? While j is smaller than probably need an n. We're just trying, and then we just keep moving to the right, right? And then we say while nums I times 2 is larger than nums j plus equal 1, right? And then when you get out, j smaller than n. When I get out, we say if j is smaller than n, rest plus equal to 2, right? And then we say rest plus equal to 2, I plus equal 1. So this one will keep moving forward until we hit one where nums I times 2 is smaller or equal to nums j. Then we will add them, and they need to both go forward. I go forward, j go forward. And then we go up. If it's good, then we go until j is out. Then we will return rest. I'm not sure. Is this gonna work? Work for this one. Work for all of them? No, it does not work for the I must have I might, if I exhausts, then that's it. Okay, I shall, wait, hold on. Is that right? So we start from here. What if I catch up to, yeah, I shall smaller than j, and dude, nope, hold on. So what you're saying is whenever I hit the 1, whenever I hit the 1 that j has gone already. Okay. So what you're saying is if I is equal to j, okay? That's what I think. No, that's not what I think. I'll have to change. Because I move forward, j move forward. So whenever j move forward, whenever they're done, right? Oh, hold on. So they go forward. Every time they're done, I can set the value to 0. Okay? So when I is equal to 0, let me hit something. and it has to keep moving forward. Has to keep moving forward until we hit something that's not 0. And what if it reaches J? Interesting thought. Interesting thought. But anyway, these are skip. These are do, right? Then we shall say nums I equals nums j equals 0. We reset to 0 and then move forward. And then for this, we should say while I is smaller than j and nums I is equal to 0, then I plus equal 1. So I'll skip all the 0, which means the one we have used already, and then we get out, right? And we say if I is equal to j when we get out, that means you're to the same position, right? The same position. Then what? J is never going to be 0 because j is always going to be forward. And when that happens, I need to reset. Okay, reset. Then j needs to equal to n plus j divided by 2. I'm just making things up at this point. Okay, so we say 0, 1, 2. Okay, I'm at 2. All right, I need to make sure the math is correct in this part. Oh, I don't need so many. What is delete? Okay, so we say if I have 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so n equal to 9. What if I add 4? What if j is equal to 4 and I equal to 4? No, I and j both are here. I need to move j forward. So I say the position is 9 plus 4 divided by 2. What is that? That's 13 at 6. So we move j to 6. That is reasonable. What if we have here n equal to 8? Then it's 8, that's 6 as well. Reasonable, okay? So this is I hit values already used. Reset j. Just try it again, right? Reset j. So everything has been used. And you reset j. And then we do this. Does this work? This one works for all of these. Okay, let's give this a shot. I mean, we have so many test cases yesterday. Is that right? We have a double. Let's see it. That shall be it. Oh, we have another one. Jeez, man. Oh, this might hold promise. Give it a shot. Oh, we got this one. Or I'm not expecting. I did not expect this one to pass, honestly. Well. So this feels greedy, right? This feels greedy to me. 2 pointers, okay? 2 pointers. First sort nums and then use 2 pointers, right? So the best we can hope for is that each small has a pairing big value. Each small value has a pairing big value. This means the small value must start from I equals 0, and the large value must start from j equals to len nums divided by 2. Okay, then we simply progress I and j forward. A few tricks to consider, right? So first of all, each time a value is used, we need to mark it by setting the value in nums to 0. I may catch up to the values used by j. Thus, each time nums I is 0, we need to keep progressing I. If I does catch up to j, we need, this is we basically return to the original position, right? And we need to reset the j position. And the others is just straightforward. So this is actually on, if you think about it, right? It's on. Because just move forward, move forward, move forward. Yeah, this is on. Okay, what is the solutions for this one? 2 pointers. You gotta be kidding me. This is it. Huh? Why mine is so complicated? 2 times this. I is 0. Okay, j is here. If it works, so this basically is saying we will just progress. We'll progress on the bigger side. All right, we'll progress on the bigger side. And if it works, smaller side move forward. If it does not work, bigger side keeps moving forward. You won't hit this problem? That's very interesting. Why I have to do all these checks? Actually, open login. So we have sorting. Forgot. Interesting idea. I mean, it does make sense, right? If you go from the bigger side, and everyone, you say, okay, divided by 2. Is it work? If it works, we take it, then we move forward. If it doesn't work, then this one go forward, go forward, go forward, works, go forward. So the ideal is when n finishes, when j finishes, the the issue now is I think this is All right, reference. Extent. Think from the point of view of the large value. Okay, it always progresses, but the small value only progress once it fits. This way, we don't have to make any additional checks. Also, the large value has to start from either the middle if nums have even counts, right? Or middle plus 1 if nums have odd counts. That's what I understand. Okay, that's what I understand. Which means we'll do the same thing. Nums sort I equals to 0. J in range. This I think is gonna be n plus 1. Right? N plus 1 divided by 2 to n. Because if it's even, that's fine, right? 6 plus 1 is 7 divided by 2 is still 3. But if it's odd, then we need to do one more, because the most we can do is n divided by 2. And then we just say, oh, and the rest. If 2 times nums I is smaller or equal to nums j, rest plus equal to 2, I plus equal 1. If not, then I stay the same, then we return rest. Ooh. Much simpler. Huh. Yep. That would still count as, no, I figured it out myself, but took a long time to figure this out. Alright, last one. I don't think I have the gun to do it now. Or save it. Minimum time to visit a cell in a grid. I always save it for another time, for tomorrow. Okay, that will be it. I'll see you guys tomorrow then. Adios.